Hello, everyone. Mr. Gale here. Miss you very much here in Toledo doing state testing. So we're going to be balancing equations all week. Just been a talking head. Wish I was there. Lots of practice here, lots of practice. So that's what we're going to do today. I'm going to turn my camera off and hopefully see you sometime next week. All right, so just a few more weeks left, January 11th. So go back and get 100% on the titled assignments. Remember, anything that says bonus is extra credit. It's not mandatory. Finish up chapter 3. We have 34 days left in the semester. Days till Christmas break, 14. And it only meets 7 more times. So I can review the tips for balancing equations using a table. All right, so tips on this balancing equations. Matter cannot be created or destroyed. So same number of molecules for each element. Subscripts cannot be added, removed, or changed at all. So in the H2SO4, you cannot change the small 2, the lower script 2, or the 4. Only can change the coefficients. So the coefficients are the number that we can put in front, which tells us we have 2 molecules. Never subscripts, never change these. Can't change them, make them bigger, smaller. Coefficients are, and you can't put a coefficient in the middle. All right, so let's try this one with a P table, or a table. The table, we have the reactant side and we have the product side. So far so we're going to put coefficients in there. So far we have hydrogen on the reactant side, which is the left-hand side. Remember, that's left and that's right. I can keep getting those confused. There are 2. And hydrogen on the product side, there are 2. Oxygen on the reactant side, there are 2, and only 1 here. So again, I look for it's out of balance, right? For the oxygen, if I take my oxygen and my balance here, there are 2 here and 1 here. So I'm going to change this to a 2. Now it's balanced. 2 and 2 on my balance for oxygen. So that means I can put this right here. Gives me 2. Changes this to 4. Now you'll notice my hydrogen is moved. So I'm going to change my hydrogen here, put a 2 here, and this becomes a 4. So now you can see 4, 4, 2, 2, perfectly balanced. All right. This is the steps. Okay, so let's balance this equation by adjusting the coefficients. So here is an example of what KClO3, or potassium chlorate. It has 3 oxygens, which are the reds, 1 green chlorine, and 1 small potassium. So let's go ahead and see what we've got so far. We have on the reactant side, we have 1 K, 1 Cl, and 3 oxygens. On the other side, we have 1, 1, and 2. So in this particular case, I need to get some multiple of the oxygens, 3 and 2. So what I'm going to do is I'm going to make 2 molecules, so 1 and 2. Now I can have multiples of 6 here, so I can go ahead and put 2 KCl here. So now I have 2K and 2K here. I have 2Cl here and 2Cl there. I have 6 oxygens here, so I'm going to put a 3 there. So let's take a look at what this video shows us.
The SAT is going completely digital. Here are 5 things to know before signing up. You can take the test.
So let's balance this equation. KClO3 yields KCl plus O2. First, KClO3 yields KCl plus O2. First, let's add up the atoms on both sides of the equation. On the reactant side, potassium, we have 1, chlorine, we have 1, and then oxygen, we have 3 of those. On the product side, potassium, we have 1, chlorine, we have 1, and oxygen, we have 2. So everything is balanced at this point except the oxygens. We have a bit of a problem. We have an even number here and an odd number over here, and that often confuses people. The strategy I like to use is get this to be an even number, and I can do that by multiplying by 2. So I'm going to put a 2 as my coefficient in front of the KClO3, and 3 times 2 equals 6. So I have 6 oxygens now. I do need to update the chlorines. I have 1 times 2. That equals 2. Potassium, 1 times the 2. And that equals 2. Over here on the product side now, I can fix the oxygens. I need 6. I just need to multiply 2 times 3. So I'll put my 3 here, and 2 times 3. That equals 6. And now my oxygens are the same. So that solves that problem for us. Also need to deal with the chlorines and the potassiums. So I have 2 Ks and 2 Cls. So if I multiply each one of these by 2, I should be okay. I'll put a 2 as my coefficient in front of the KCl. So 1 times 2, that equals 2. And then 1 times 2, that also equals 2. And now everything on each side of the equation is the same. This equation is balanced.
Okay, good way of talking about this. All right, so let's go ahead and balance some more equations. MgClO3 in parentheses. So this is a little more confusing to count the atoms here. So Mg, we have 1. Now this, again, we can put that subscript there. 2 times 1, this parentheses just goes for this ClO3, the chlorate. So it is Cl will have 2, oxygen will have 6, 2 times 3. Right, on this side we have 1 Mg on the product side. This is the reactant side. The Cl we have 2, and the oxygen we have 2. So looks like we don't really have to change too much except for the oxygen, and it's low on the reactants on the product side. So let's keep these at 1, and let's go ahead and make this 3 times 2 gives me 6. So we have everything's balanced. 6 oxygens, 2 chlorines, and 1 magnesium on each side. All right, so let's fill in the word bank. Let's kind of review what we've talked about so far. Atoms are not created or destroyed. That's the law of conservation of mass. We have, and the balancing of the atoms is what's telling us that. During a chemical reaction, scientists know that there must be the same number of atoms on each side of the equation, or the reaction. Here's reaction. To balance the chemical equation, you must add coefficient in front of the chemical formulas in the equation. You cannot subtract or add to the subscript. All right, created, destroyed, added. So I've got backwards. All right. Even versus odd multiples, the entire equation by 2 to get the even coefficient. Leave H and O to balance last. Recount each element on both sides after adding coefficients every time. All right, so let's balance this one. So we have iron in the reactant, we have 2. Oxygen, we have 3. Hydrogen, we have 2. And we have 1 SO4. So we're looking at this 1 SO4. Think of that parentheses here because this is considered as, with a subscript, 2 subscripts, it's kind of 3 SO4s. So on this side we have 2. Iron oxygens, we have 1. Hydrogens, we have 2. And SO4s, we have 3. Right. Okay. So let's try this out. Let's go ahead and put a 3 here, and that'll get my SO4. So if I can kind of think about this as 3 times that, that'll get my SO4s the same. So I'm going to make this a 3. And now the only thing different here is I've got 3H2. So let's go ahead and put this here, 3. So now we'll have 6 hydrogens on each side. All right, let's count the oxygens here. 3 oxygens. And that balances this out. Balancing equations. So let's take a look at this one.
Make this Christmas season a crafting season at Hobby Lobby and save 50% with our Christmas sale. We have holiday goodies for the whole family to love, and at a price you'll...
Okay, to balance this combustion reaction, we'll first draw a table so we can account for all of the atoms. So on the reactant side, we have a carbon, hydrogen, and oxygen atoms, and we have 2 carbons, we have 6 hydrogens, and we have 2 oxygens. On the product side, we have only 1 carbon, we have 2 oxygens here, but we also have 1 over here with the water. So we have a total of 3 oxygens. Let's start by fixing the carbons. I need 2 on this side. So if I put a 2 right here, 2 and the 1, that'll give me 2. But now I've got to update my oxygens. So let's delete that. We have 2 times 2, 4 oxygens, plus that 1 we have with the water. So we have 5 oxygens. I need 6 hydrogens on both sides. So 2 times 3, that'll give me 6. So let's put a 3 here. 2 times that 3. Now we have 6 hydrogens. That's balanced. But our oxygens have changed again, so we need to update that information. So we have 2 times 2, that's 4, plus we have the 3 times the 1, that's 3. So we have a total of 7 oxygens. And this is where it gets a little awkward. You have 7 oxygens here and 2 oxygens here. You can't easily multiply to get a whole number. But what we could do, we know 2 times 7 over 2, that would equal 14 over 2, or 7. So if we put a 7 over 2 right here, our equation's balanced. Now we don't have whole numbers yet, but that's pretty easily remedied. Let's multiply the entire equation by 2. So if I multiply this by 2, the coefficient would be 2. 2 times 7 over 2, well, that equals 7. 2 times 2 is 4, and 2 times 3 is 6. Now I can just replace those numbers with the coefficients in blue. So by doubling these, I have the same ratio, which is the key to balancing equations, and I don't have any fractions in it. I have whole numbers. So
All right, so let's balance this chemical equation. All right, so Na and Cl, so let's go ahead and give myself a pen here. Made a mistake, this is Na. So we have 1 Na, 2 Cl, 1 Na, 1 Cl. So because the product side is kind of light, I'm going to put my coefficient in front of the Na. So that'll make these both 2. And then all I have to do is put a 2 in front of the Na, and it's complete. So you can tell there's some harder problems than others. We've tried some different ones that are more difficult. And again, trial and error is the best way to try it. Try a number and then see if continue working through them till you get balanced equations. Let's take a look at this video here.
It's Michael's big holiday sale. Deck your halls for less and get up to 50% off from trees, ornaments.
equation. First, we're going to figure out how many of each type of atom we have on each side. So I'd like to draw a line across like this, and then like this. And what I can do now, I have carbons, hydrogens, and oxygens on both sides. So if I count my carbons up on the reactants, I have 1 for my hydrogens, I have 4, and there are 2 oxygen atoms. On the product side, I have 1 carbon, I have 2 hydrogens, and then I have 2 oxygens with the carbon dioxide, but I have 1 oxygen atom with the water. That gives me a total of 3 oxygen atoms on the product side. So the carbons are balanced. We don't need to do anything with that. Let's take a look at the hydrogens. If I were to put a 2 right here, that would mean I would have the 2 times 2. That would give me a total of 4 hydrogens. Now the hydrogens are balanced. The problem is, though, that I still have the 2 oxygens with the carbon dioxide, but now I have the 2 times the oxygen. So this becomes 2, which means 2 plus 2. I have a total of 4 oxygens on the product side. I go back to the reactants and I put a 2 right here. 2 times 2 equals 4. And now all of the atoms on each side are balanced. I have the same number of each atom on each side of this equation. When you have these
Okay, so we're going to stop right there, ladies and gentlemen, and give you some practice problems to work on. Enjoy your day. Thanks a lot. Oops, let me do this. Thanks a lot, guys. I will see you tomorrow.